This video and other videos for Comp Arc 211 can be found here at Sarai Studies. Link is in the description box below. Here we have a truth table, and truth tables have inputs. In this case, the inputs are A and B, and depending on what the inputs are, we get a different output, and we call that output F. So the last column of your truth table is always your output column. It contains all of the possible outputs. So in this case, we're defining F to be 1, 0, 1, 0. That's all of the possible values that F can be. But what if we had many more outputs? Instead of defining F to be 1, 0, 1, 0, 1, 0, blah, 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 it could be a long list of outputs. The question becomes, is there a less tedious way to do this? Is there a more compact way to represent all of the outputs of a truth table depending on what A and B are? And the answer is yes. That thing is called a formula. Now, there are three methods to find a formula that represents a truth table. The first method is to find all of the cases when the output is true. What's the output? F. This could have been Y, it could have been R, it could have been whatever variable, but we're going to replace this with F. Recall that true means 1. So if we're looking for when F is true, we're really looking for when F is 1. So F is 1 here and here. So instead of defining our output to literally be the list of all possible outputs, 1, 0, 1, 0, we can define our output as all of the cases when our output is true. So we can say that our output is equal to the first case, which is when A is false and B is false. So if you have any input, if it's true, then you can just write it as is. If it's false, which is the opposite of true, then you want to do the opposite of that, which is A prime. So the first case when F is true is when A is false, so A prime, and B is false, so B prime. Now remember, in formulas, we don't like words. We like to use operators. So you have to recall that we can represent and with multiplication and or with addition. If you ever forget, look at the word and. The N can be made an M just by adding one line and then think M for multiplication. So we can replace this with multiplication, which we don't even need because we could just put these things together like so. And this represents one case when F is true. So we're saying F is true in this case, or is represented with addition. The second case for which F is true, and that is when A is true and B is false. So we have A being true and B being false. That is the second case. And that's it. This is the formula that represents all of the possible outputs of the truth table depending on whatever you plug in for A and B over here. Now the second method is exactly the same thing but the opposite. So if we found F here, we're going to find not F in the second method. And how do we represent not? With a prime or a bar. So essentially we're looking at F prime and we're defining F prime as all of the cases when F is false. So it's literally just the opposite. But the problem is if we're going to find F prime, our goal is to actually find F. So how do we go from F prime to F? Well, we take the complement. Complement also just means opposite. So if F prime is going to be all of the cases for when the output is false, if we take the opposite of that, the complement, then we're taking the opposite of all the false cases, it's going to give us the true cases. And so we're going to get F. So the output, remember, is F, and we're looking for when it's false. False means it's 0, so we're looking for when F is 0, that's here and here. So the first case when F is 0 is when A is false and B is true. So we have A prime and B is true, but again, and is represented with multiplication, so we change this to multiplication, which we don't even need to because we could just write it as such. Or, remember, or is represented with addition. Another case for when F is false is over here, when A is true and B is true. So A is true and B is true, but again, we can represent and with multiplication, change that to multiplication. We don't really need it. We could just write it as such. And this is F prime. To get F, we take the complement, which is just a fancy way of saying, hey, take the opposite of everything. So we're going to take the whole thing and take the opposite of everything. Remember, not, bar, prime, complement, they all mean opposite. So what we're essentially doing is taking the opposite of something that's already the opposite. So these are just going to cancel out and leave us with F. So when we're taking the opposite of every single thing in here, including the signs, even the signs in between. So here we have multiplication, here we have multiplication. We also have to take the opposite of those as well. So the opposite of A prime will just be A. The opposite of B will just be B prime. The opposite of the multiplication sign that's in between is going to be plus. The opposite of multiplication is addition. The opposite of this is going to be multiplication. The opposite of A is going to be A prime. The opposite of B is going to be B prime. The opposite of the multiplication sign that's in between is addition. We can get rid of this multiplication sign and have these be parentheses, and this is our formula. Now you might be like, wait, Sarai, this is not the same formula that we got in method 1. And that's fine. You can have different ways to express the formula, but they all mean the same thing. These are the same. They will all, depending on whatever A and B you input, are going to give you the same output, which is why in the beginning I said that we're going to work on 3 ways that we can get a formula. I didn't say the formula. There's no one single formula. There can be multiple formulas for a truth table and they all mean the same thing. Now the last method is using a KMAP. So they usually teach this topic at the end right before the first midterm, but I'm going to introduce it here so you can see all of the 3 methods for getting a formula from a truth table. But K-maps are a little bit different depending on how many inputs you have. But the idea is you start with a rectangle, and the easiest thing is to find out how many boxes you need. It's the number of rows. So here we have 1, 2, 3, 4 rows, so you're going to have 4 boxes. Then we usually draw this line over here. And what goes on top and below our line are our inputs. So we have input A and B. So the first one that we see goes on top, the second one we see goes on the bottom. Then what goes along these axes over here are all of the possibilities of A, are all of the things that A can be. If you go through A, the only thing you see that it can be is 0 and 1. So you do 0 and 1. So you wouldn't do 0, write 0 here, and then write 0 again. No, you already have that as a possibility. So you skip that and you move on to 1. You write 1, and then you go and continue searching for anything else that A can be, and you don't see anything else that A can be because you already wrote down 1. Same thing with B. B can be either 0 or it could be 1. Now to fill it in, you go through each box. So you ask yourself, when A is 0 and B is 0, what is the output? Well, when A is 0 and B is 0, the output is 1. Now you ask yourself, when A is 1 and B is 0, what is the output? Well, when A is 1 and B is 0, the output is 1. Now to find this output, look for when A is 0 and B is 1. A is 0 here, B is 1 here. The output is 0. And finally, we're looking for when A is 1 and B is 1. A is 1 here, B is 1 here, the output is 0. Now, how do you get a formula from this KMAP? Well, the goal is to always make the biggest groups of ones that you can, but there are some rules. First of all, your groups can only be squares. So if there was a 1 here, I can't do something like this, like an L shape. That's not a square. If there was a 1 here and this was a 0, I couldn't do a group like this because that's also not a square. The second rule is that the number of ones in your groups can only be powers of 2. So you can have 0 ones in a group, 1 1 in a group, you can have 2 ones in a group, 4, and so on. In this case, I can make a group of these 2 ones, and what you want to make sure is that your groups have something in common. So you ask yourself, what does this group here have in common? They don't have the column in common, but they do have the row in common. In other words, no matter what A is, B is always false for this group of ones. So your formula is going to simply be equal to B prime. Because remember, if you have something like B, if B is true, then you can just write B, but if B is false, then you write the opposite of B, not B, so that's B prime. At the end of the day, what this is saying is that your output is simply going to be the opposite of B, no matter what A is. So no matter what A is, if B is 0, your output will be the opposite, 1. If B is 1, your output will be 0. If B is 0, your output will be 1. If B is 1, your output will be 0. It's always the opposite of B. And so hopefully you notice that the KMAP method is always going to give you the simplest expression for your formula. So if you're given a truth table and you're asked to find the formula for this truth table, all of these formulas here are acceptable answers. They don't look exactly the same, but they are equivalent because if you pick any A and B and plug them into each of them, you'll get the same output. Now, you might be like, I'm not going to bother learning these 2 methods because if the KMAP gives me the simplest expression or the simplest formula, then I'm just going to use the KMAP method all the time. Well, that's fine and all, but they're probably going to ask you to use a specific method, so you need to know what they are. And they're not going to say use method 1, method 2. There's names to these methods. So the name of method 1 is the sum of products, because the formula is literally the sum of products of things being multiplied together. The name of method 2, remember method 2 is the opposite. Here we found all the cases when f is true. Here we find all the cases when f is false. So the name of the method is literally the opposite as well. You're just switching the letters. So it's the product of sums. You just switched S and P because you literally see the product of sums of things being added together. And then obviously this is called the KMAP method. So what they're most likely to do is say, hey, here's a truth table. Express the formula for this truth table as a sum of products, as a product of sums, and also by using a KMAP. So just remember, sum of products, true. Product of sums, false. Take the complement so you can actually get F. And then KMAP will always give you the simplest Boolean expression, the simplest formula for your truth table. Now, one last piece of vocabulary. These things here are called minterms. These things here are called maxterms. So minterms are ones separated by multiplication. Maxterms are separated by addition. The way that I remember it, I think of it as a number line. My name is Sarai. So I always remember, as for Sarai, Sarai comes first, so this comes first. Or you can think, if you're a finance major, the S&P 500, the 500 is irrelevant, but the SP goes in order. So S comes first, and then product of sums. And then think min, think small, think negative numbers, so that's min, because negative numbers come before positive numbers, and think max as big numbers. And so you'll remember that min terms are what you call those that are separated by multiplication, which is what you get when you're expressing the formula as a sum of products, and max terms are what you call call these when separated with addition, which is what you get when you're working in the product of sums. On another note, because we call these minterms, another name for this method, for the sum of products method, is the sum of the minterms, the sum of minterms. And later on, when we learn about machines, we're going to learn about a decoder, and this is key to understanding what a decoder is and how it's useful. Likewise, because these things are called maxterms, another name for method 2 for the product of sum method is the product of the maxterms. And finally, I did mention that KMAPs find the simplest formula. It gives you the simplest sum of products form. But another way to get the simplest sum of products form is to take the sum of products and simplify it, literally. So if you've taken discrete, this is a whole section. It's called equivalence of propositions. And if you have Miranda, he gives you a cheat sheet, and it's just a list of all of the identities, all the laws that you can use, and then you just use those to simplify your expression. In this class, they just call it Boolean Algebra. So I'll show you how to simplify your formulas so that you can get the simplest formula in the next video.